All right, today's lesson is about seasons. And there's two different pieces to this. The first thing, and this is not exactly directly related to seasons, but it's one of these things that I kind of have to go over. And when we start talking about tides and those types of things, this will come back into play. But one of the things that you need to know is, I guess the question we have to ask is, if you look up at the moon at night, you're going to notice that we always see the same side of the moon. Always. It never turns, and people like to think, oh, well, we always see the same side of the moon, so obviously the moon is not rotating. And that is actually not true. The moon does rotate, and I'm going to try to show you. So if this is the Earth and this is the moon, you'll notice there's a piece of red paper right there. That's the side that's always facing the Earth. Now, as the moon revolves around the Earth, it's also rotating. So as it revolves, it rotates. And as it rotates, it always turns that face of the moon back towards the Earth. If it didn't rotate, it would come around like this, and then the face would be going that way, not facing the planet. So it rotates at the same speed that it revolves around the Earth. And by doing that, it always keeps that same side of the moon facing the Earth. That's one of those little things that, although it seems like it's really not important, it's really important to understand that the Earth rotates, the moon rotates, the Earth revolves around the sun, the moon revolves around the Earth, and the process together always keeps the same side of the moon facing the Earth. So I hope that is able to clear that part up a little bit. Really, the focus of this lesson is going to be on seasons. Now, the hardest thing for people to understand is it doesn't matter, and you got this in the last video when we talked about the speed of the Earth as it goes around the sun. This is showing pretty even here, but if you remember, let me jump back to this picture. Part of the Earth's rotation here, revolution, use the right vocabulary, revolution around the sun is closer to the sun than the other side. So this is further away, this is closer. The further away the Earth gets, the slower it moves. As it makes this corner and starts coming back, it gets faster and faster and faster until it gets to this point right here where it starts to slow down as it comes around this corner because the gravity of the sun is pulling down on it. Now, that piece is important, but remember that has nothing to do with seasons. If we're looking at seasons, what we're looking at is the tilt of the Earth on its axis and what direction is the tilt pointing. Now, if we remember back to our discussion of the lines of latitude. So lines of latitude determine the climate that you have. The further north the line, the colder the climate. The closer to the equator the line, the warmer the climate. So the further away you get up here, it's going to be cooler. Down here, it's going to be cooler. But if you're between these two sets of yellow lines, the Tropic of Cancer and the Tropic of Capricorn, it's going to be pretty warm all the time because that's considered the tropic zone. Now, what's that have to do with the seasons? Well, remember what I said. The tilt of the Earth is at 23.5 degrees. The Tropic of Cancer line and the Tropic of Capricorn line are at 23.5 degrees. What that means is if we're in the northern hemisphere, so that's up here where this is pointing towards the sun. This is summer for us. This is winter because the North Pole is pointing away from the sun. So if this is summer, And this is winter. This is fall, September, October. That's fall. And the sun is hitting directly on the equator. And this is spring, and the sun's hitting directly on the equator on the other side. Now, because the tilt of the earth has the axis pointed towards the sun, the sunlight, the focus of the sunlight is on the Tropic of Cancer, 23.5 degrees. That's as far north as direct sunlight will go. So from here, the direct sunlight is on the Tropic of Cancer, northern hemisphere. It's summer for us. As the earth moves around, as the earth moves around the sun, the sun, remember we said this is summer. As the earth moves around the sun, when we get to fall, the direct sunlight drifts down until the direct sunlight is focused on the equator. That's fall. And then as the earth continues to work around to where the North Pole is pointing away from the sun, the direct sunlight's going to work south until it's pointed directly at the Tropic of Capricorn in December. And that's winter for us. So we're talking about where the direct sunlight hits the earth. So Tropic of Cancer, that's where the direct sunlight hits during the summer. Tropic of Capricorn, that's where the direct sunlight hits in the winter. And the equator is where it hits in the spring. Now, it's this cycle, like a lot of things in nature, it's this cycle. So if we're in summer and the direct sunlight is hitting Tropic of Cancer, and then we go in, let's see, that's June. June is the summer solstice. And then we go into July, and then August, and then September, we're at the equator. Direct sunlight's at the equator. And then October, and then November, and then December, direct sunlight is on the Tropic of Capricorn. And then it goes back up. So January, February, March, we're back at the equator. Direct sunlight, remember, direct sunlight. And then March, April, May, June puts us back at Tropic of Cancer for summer. So that being said, it's just to help you understand why there are seasons. The tilt is the reason we have seasons. If there was no tilt, if the tilt was 0 degrees and the North and the South Pole were straight up and down, then the direct sunlight would always be on the equator, and we would be in eternal spring, eternal fall. Because it's that tilt is what gives us our seasons. Now, yes, it's the revolution. It's going around because of the tilt is what causes the change. But it's the tilt is the reason that we have seasons. I hope that kind of illuminates you to a little more specifically on how seasons are. The one other thing that we have to remember is the equator separates the planet into northern hemisphere and southern hemisphere. If the sun is pointing at the Tropic of Cancer, for us, that would be summer. We already mentioned that. But that means everybody below the equator down here, if we're in summer, they're in winter because the sun is pointing away from them. It also means their days are shorter. Our days are longer. As we move to autumn or fall, our days are getting shorter, but the days in the southern hemisphere are getting longer. And then when we get to what is winter for us, northern hemisphere, we have short days. Southern hemisphere has summer. They have long days, and it continues that cycle. Some people get confused. We start talking about Christmas. If we've got friends who live in Australia, and we talk about Christmas and we talk about decorating Christmas trees. Well, when they think decorated Christmas tree, they're actually thinking decorate a palm tree because it's summer for them. Christmas is a summer holiday south of the equator. North of the equator, it's a winter holiday. But it's all because of how seasons are with the tilt of the earth. I hope that's helped to clear things up. I know some people struggled with that. If you need any help, hop on Microsoft Teams and I'll be glad to help. Have a good day.